Question 9. In June 2016, the UK held a referendum on its membership of the EU. Table 1 below summarises the results. The table contains the number of votes in several categories. The number of votes to leave the EU, to remain a member of the EU, the number of valid votes, and the total number of votes. Our first task is to write the number of invalid or blank votes into the table. The key observation here is that together the valid votes and the invalid or blank votes will make up all the total votes. In other words, if we add together the valid votes and the invalid votes, we'll get the total votes. Another way to view this is that the invalid votes is equal to the total votes minus the valid votes. So let's do this calculation. So our final answer here is that there were 25,359 invalid or blank votes. Part II. Write the number who voted to leave the EU as a percentage of the valid votes. Give your answer correct to the nearest percent. Looking at our table, there were 17,410,742 votes to leave the EU. There were 33,551,983 valid votes. To find the proportion of people who voted to leave out of the valid votes, we divide these two numbers. We need to present our answer as a percentage. To convert this fraction to a percentage, we multiply by 100 and write in a percentage symbol. Doing the calculation here, we'll get an answer of 51.8918%. The question asks us to give our answer correct to the nearest percent. In other words, the nearest whole number. When we do this rounding, we get an answer of 52%. So our final answer is that 52% of the valid votes were votes to leave the EU. Part B. Table 2 shows the percentages of remain and leave voters in various age groups of those who voted in the referendum. Draw a suitable chart or charts to represent the data in Table 2. Taking a look at our table, we have the various age groups in the first column. The second and third columns give us the percentage of voters who voted to remain and leave in each of these age groups. For example, our first row here says that 73% of 18 to 24-year-olds voted to remain and 27% of 18 to 24-year-olds voted to leave. For our chart, we'll want to be able to compare the remain percentage versus the leave percentage for each of these age groups. A bar chart is suitable for this purpose. In this bar chart, I'll label the horizontal axis with the age groups. I'll label the vertical axis with the percentage of vote. The idea here is that for each age group, there's two percentages that we're concerned with. The percentage that voted to remain and the percentage that voted to leave. We can draw two bars side by side to represent this. Let's start with the 18 to 24 age group. Here, 73% voted to remain. So I'll draw in a bar with a height of 73%. 27% voted to leave. So I'll draw in another bar, this time with a height of 27%. The colour coding here is that I'm using orange for the remain votes and purple for the leave votes. So let's look at the next age group, 25 to 34. Here, 62% voted to remain. So in orange, I'll draw a bar with a height of 62%. 38% voted to leave. So we'll draw another bar in purple with a height of 38%. The rest of the age groups work in a very similar way. We look at the percentage of the remain votes and the percentage of the leave votes and draw one bar for each of them. We've now drawn in the bars for each of the age groups. So our bar chart is complete. Part II. Find the mean of the remain values given in Table 2 and find the mean of the leave values given in Table 2. Give your answers as percentages, correct to 2 decimal places. The key fact that we need to know to be able to solve this question is the following. To find the mean of a list of numbers, we add up all the values and then divide by the number of values. We need to find two means here, the mean of the remain values and the mean of the leave values. Let's start with the remain values. The values here are 73, 62, 52, 44, 43, and 40. To find the mean, we have to add all these values up and then divide by the number of values. Well, if we go to the calculator and add up the numbers, we'll get an answer of 314. If we count up the number of values on our list, we'll see that there is 6 numbers. To find our mean, we divide the sum, 314, by the number of values, 6. Rounded to 2 decimal places, our answer is 52.33. The values we were working with represented the percentage of people who voted to remain. So our unit here is a percentage. So our answer here is that the mean remain percentage is 52.33. Finding the mean of the leave values works in a very similar way. Here, our values are 27, 38, 48, 56, 57, and 60. If we add up all these numbers, we get an answer of 286. If we count up the number of values, we see that we have 6 values on our list. To find our mean, we divide the sum, 286, by the number of values, 6. So, rounded to 2 decimal places, the mean leave percentage is 47.67. Part III. Explain why the answers to Part BII do not accurately reflect the actual outcome of the referendum. In Part BII, we showed that across the age groups, the mean leave percentage was 47.67 and the mean remain percentage was 52.33. Here, the mean remain percentage was larger than the mean leave percentage. However, in Part AII, we showed that overall 52% of people voted to leave, and hence 48% of people voted to remain. So overall, the leave percentage was larger than the remain percentage. The question is essentially asking us why these two things aren't in sync. In other words, why is it the case that when we look across age groups, the mean remain percentage is higher, but when we look at things overall, the leave percentage is higher? And the key observation here is that the number of voters in each of the age groups is important. Let's illustrate this with an example. The first age group in our table is 18 to 24. This interval spans 7 years. The last age group in the table is 65 plus. So this includes all the voters who are over 65 years old. There were probably voters who were 90 or even 100 years old. So I'd suspect that this interval spans over 30 years. So when we think about it, we would certainly expect that there will be a lot more people in the 65 plus age group than the 18 to 24 age group. This means that having a large percentage of the vote in the 65 plus age group is much more significant than having a large percentage of the vote in the 18 to 24 age group. When we calculated the mean percentages from our table, each age group carried equal weight. However, this is not representative of the actual votes. The age groups with a bigger number of voters should have been given a bigger weighting. So, in summary, the answer in BII does not accurately reflect the actual outcome because it does not account for the number of voters in each of the age groups. Part C. In the days following the UK referendum, a survey was conducted in Ireland on attitudes towards a British exit from the European Union. 1,200 people were surveyed. Find the margin of error of this survey. Write your answer as a percentage and give your answer correct to the nearest percent. We are asked to find the margin of error. The key to solving this question is the following fact. The margin of error is 1 over the square root of n, where n is the sample size. In this context, the sample size refers to the number of people who were surveyed. We were told that 1,200 people were surveyed. So our sample size, n, is equal to 1,200. We know that the margin of error is 1 divided by the square root of n. So here, that's 1 over the square root of 1,200. If we type this into our calculator, we get 0.0287. We are asked to write our answer as a percentage. To convert this to a percentage, we must multiply by 100 and put in a percentage symbol. If we do this, we get an answer of 2.87%. We were asked to give our answer correct to the nearest percent. So to finish off, we need to round this to the nearest whole number. This gives us a final answer of 3%. Part II. In the Irish survey, 578 of the 1,200 surveyed agreed that a UK exit would have a negative effect on the Irish economy. Use your answer in Part C(I) above to create a 95% confidence interval for the proportion of the Irish population who agreed that a UK exit would have a negative effect on the Irish economy. Well, Finding a 95% confidence interval boils down to the following two steps. Firstly, we calculate the sample proportion. And secondly, we subtract the margin of error to get the lower bound of the interval, and we add the margin of error to get the upper bound of the interval. Let's start with step 1. We are told that 578 of the 1,200 surveyed agreed that there would be a negative effect on the Irish economy. So here, our sample proportion is 578 over 1,200. If we type this into our calculator, we get 0.4817. The margin of error we found was in percentage form, so it will be useful to write this as a percentage also. To do this, we multiply by 100 and write in a percentage symbol. This gives us 48.17%. Now for step 2. From the previous part of the question, we know that the margin of error is 3%. To find the lower bound of our confidence interval, we subtract the margin of error from the sample proportion. Here, we get 48.17% minus 3%, which is 45.17%. To find the upper bound of the confidence interval, we add the margin of error to the sample proportion. Here, we get 48.17% plus 3%, which is 51.17%. So, we know the lower bound of the interval is 45.17%, and the upper bound is 51.17%. So our final answer is that the 95% confidence interval is 45.17% to 51.17%. Part III. After the survey, a political party claimed that 53% of the Irish population believed that the decision of the UK to leave the EU would have a negative effect on the Irish economy. Use your answer to part CII above to conduct a hypothesis test at the 5% level of significance to test the party's claim. Give your conclusion in the context of the question. In this question, the political party's claim involves the proportion of the Irish population who believe that the decision of the UK to leave the EU would have a negative effect on the Irish economy. Let's let P denote this proportion. Hypothesis testing involves a number of steps. The first step is to state the null hypothesis, H0, and the alternative hypothesis, H1. Typically, the null hypothesis corresponds to the assumption or the claim that is being made. In our question, the political party is claiming that 53% of the population believe there will be a negative effect on the Irish economy. In other words, they're claiming that our proportion, P, is equal to 53%. The alternative hypothesis represents the alternative options if the null hypothesis is not true. Here, the null says that P is equal to 53%. The alternative is that P is not equal to 53%. Step 2 is to create a 95% confidence interval for the data. And we've done this in the previous part of the question. We found that our 95% confidence interval is 45.17% to 51.17%. The third step is to look at the value for the null hypothesis, H0. If it is inside the confidence interval, then we fail to reject H0. On the other hand, if it's outside the confidence interval, then we reject H0 and move to H1. In our question, the null hypothesis assumes that P is equal to 53%. 53% is outside of our confidence interval, 45.17% to 51.17%. This means that we reject the null hypothesis H0 and move to the alternative hypothesis H1. The final step is to state your conclusion in the context of the question. In our question, the political party's claim corresponded to the null hypothesis. P is equal to 53%. We rejected the null hypothesis. So in the context of the question, we rejected the political party's claim that P is equal to 53% and moved to the opinion that P is not equal to 53%.